Hi everyone, in this video we want to talk about concavity and inflection points. So the first question is, what is concavity? Concavity measures how the slope of the function, and the way to think about it is it measures how the graph is bending. So if you have a graph of a function, how can you see the concavity on that graph? And the answer is that a function is concave up at x equals a if the graph of f of x is above its tangent at x equals. So I'm looking here at places where I can see that the graph is above its tangent line. So there's one, for instance, right here. If I sketch the tangent line, I can see that at this point, the graph is definitely above the tangent line. There's another one right here. I sketch the tangent line, and it's clear the graph is above it. So at these 2 points that I've labeled in blue, the graph is concave up. Now let's look at some places where the graph is concave down. So I'm looking now for places where the graph is below its tangent line. So there's one right here. Let me do this in red so that it's clear these two are distinguished. So if I sketch the tangent line here, the graph is below the tangent line at this. Is there anywhere else that's true? Yes, over here is another place. So it should be fairly straightforward to see places where the graph is concave up or concave down. Now, how do I see concavity on a graph using secant lines? Remember, a secant line is a line between 2 points, where a tangent line is a line at a single point. So the way to look at that is to remember that you're looking here over an interval. So when I have the graph of my function, y equals f of x, if I draw a secant line and the graph is above the secant line, then I can say that the function is concave up on the whole interval. And it's the same relationship with concave down. So for instance, let's look at these 2 points. Here I have this point and I have this point, and then I'm going to draw the secant line connecting these 2 points. Well, everywhere on that interval from A to B, it's true that the graph is above this tangent line. So the conclusion is that this graph is concave up on the interval AB. Now, if I draw another point here called C, everywhere on the interval CD. And this is weird because we're thinking about concave up at a single point, concave down at a single point being defined by the tangent line, and we're looking concave up and concave down on an interval being defined by the secant lines. A function is concave up on an interval AB if the function is concave up on every point in AB. So that's the relationship. And you can see that if I went back to my secant line criterion, if I drew a tangent line at any point in this interval AB, I'd be seeing the curve be above that tangent. That can be a little bit hard to remember because concave up is above for tangent lines and below for secant lines, but it's just something that you get used to. Well, common confusion that students often have is they get concave up and down mixed up with increasing and decreasing. And these are totally different ideas and totally different things. Why would we have both? Why would we create concave up and down as a concept if it was the same thing as increasing and decreasing? There's basically no relationship between them. So if you look at just another graph that we're going to squiggle real quick, there are places where the graph is concave up and decreasing. There's one right here. There are places where f of x is concave up and increasing, and there's one right here. There are places where f of x is concave up. There are places where f of x is concave down while it's increasing. And there's a place right here you can see where f of x is concave down and decreasing. So it's important to recognize that these are actually independent concepts and worth holding on to. So that's the visual aspect of concavity. You should know what concavity looks like using tangent line or secant lines. The next question is, how do I determine concavity from a formula? So f of x is concave up is the same thing as saying that f double prime of x is positive. And f of x concave down is the same as saying that f double prime of x is negative. So we have this relationship that you can determine the concavity of f of x by looking at the sign of the second derivative at a particular number. This is definitely one of the things that's worth writing down and making a note of because it's extremely important.